again, first start. Oh, it's frozen. A first start is to factor completely. So if we factor this completely, we'll get x plus 3, x minus 3 over 2x. The non-permissible value is that x can equal 0. And in this case, that will give you a vertical asymptote at x equals 0. X-intercepts and y-intercepts, well, the y-intercept is when you plug in 0 for x. Can you see that this one would have no y-intercept? Because 0 is a non-permissible value. So because there's an asymptote at 0, we can't have a y-intercept. X-intercepts, though, there's going to be two of them, one at negative 3, 0, and one at positive 3, 0. If you plug in 0 for y, the only place a fraction is equal to 0 is your numerator. And so, since our numerator is factored, that makes our x-intercepts easy. If we wanted to graph this one completely, well, we have a bigger degree on the top than the bottom. Okay, so we would need to find an oblique asymptote for this one, since nothing simplifies. Okay, in this case, because we're dividing by 2x, you can't use synthetic division. You would have to go to long division to find your oblique asymptote. So what would give me x squared would be a half x. 1 half of x times 2x would be x squared. Subtract, and we just get 9. Kind of a different one, so the remainder is 9. So our oblique asymptote is at y equals 1/2 x. We have enough information now. Our vertical asymptote is at x equals 0. Our oblique asymptote rise of 1, run of 2. Would look like that. We know that our x-intercepts are 3, 0 and negative 3, 0. Draw your graph towards the asymptote. And we are done. So this one, a little bit different because of the fact that you couldn't use synthetic division to find the oblique asymptote. You had to use long division. So what we find with these graphs, and the reason we've been practicing so much with them, is that there is so many different, even though the steps are the same, there's so many different situations that could come up. All right, let's look at the second one as well. Again, start by factoring it. X can't equal 3, and x can't equal negative 1. Nothing cancels out, so both of these will become vertical asymptotes at x equals 3 and x equals negative 1. Next, this one, we can find a y-intercept. If you plug in 0 for x, especially in the original equation, it's really easy to figure out. You get 2/3. This one has an x-intercept. the only place our numerator is equal to 0 is when x is 2. For our other asymptote, here we notice the degree is bigger in our denominator. Anytime your degree is larger in your denominator, we have a horizontal asymptote at y equals 0. If we went to graph this one, y equals 0 is our asymptote, 3 and negative 1. X equals negative 1. X equals 3. And we have an x-intercept at 2. And our y-intercept was at 2/3. So we can label those points. 0, 2/3, 2, 0. Now a couple of things. First of all, since these connect, you would know towards the asymptote it has to go up, because if it went down after they connected, you would create another x-intercept, and we found out that the only x-intercept is at x equals 2. Sometimes in this section, students don't know if they should go up or down. Okay, in this case, it's going to go down. One of the ways you can tell that it's going down is the multiplicity of the x-intercept of x equals 2 is just 1, so it has to go straight through. You could also plug in another nice point. In this case, the other nice point you'd have to plug in would be like 2.5 to find out what it's equal to, and you would discover that there would be some point down here, which means that it has to be below that way as well. Okay? If we were graphing this one, we would also have to find a nice point when x is equal to negative 2 and when x is equal to 4. Something in the sections that are missing. So if you plugged in negative 2 into your original equation, you would get negative 4 over negative 1 times negative 5, negative 4/5. And if you plugged in 4, you would get 2 over 5. So if we add those points to our graph, negative 2, negative 4/5, then this graph in this section has to look like this, and 4 and 2/5. Then we would know the graph in this section looks like that. Then for the construct the understanding, same idea. But in this case, we're going to factor first, always, and something nice happens. One of our non-permissible values cancels out. So our non-permissible values, x can't equal negative 1, and x can't equal positive 1. The negative 1 non-permissible value stays. But the positive 1 non-permissible value gets simplified, and when things get simplified, they become a whole. And when it simplifies, our new equation, which I wrote in blue, is y equals 1 over x plus 1. And this is the first time that we've had a whole where the new equation isn't a line. Okay, number one mistake I see in this one is students cancel things out, and when they write the blue equation, they just write y equals x plus 1. The x plus 1 is still in your denominator. It can't move out of your denominator. So our hole, if we want to find it, well, we plug in 1 into the blue equation. That's easy enough. We know where our hole is. It's going to be at 1, 1/2. But now, we go through and we still have a rational equation. So we still have to go through the rest of the steps for the rational equation. We're done our vertical asymptotes, okay? But we also need to find out, is there a horizontal asymptote or an oblique asymptote? And now we deal with the blue equation moving forward. Can you see that the degree is bigger in your denominator? Anytime your degree is bigger in your denominator, you have a horizontal asymptote at y equals 0. What's our y-intercept? Well, if I plug in 0 for x, and now I'm going to plug it into my new equation. So once things have been simplified and you continue graphing, from now on you're using that blue equation for everything. So if I want to find my y-intercept, I plug in 0 for x, I use the blue equation. If I want to find my x-intercept, I also use the blue equation. And in this situation, there's none. There's no x-intercept because the only place you'll get an x-intercept if something makes your numerator equal to 0. Can you see your numerator is equal to 1? It will never equal 0. So when we go to graph this, we can add our asymptotes in. We have an asymptote at y equals 0, and we have an asymptote at x equals -1. We have a y-intercept at 0, 1. And we have a hole at 1, 1/2. This section, we have enough information to draw it towards the asymptotes. But we will need one nice point in this section. So I would choose -2. Again, I plug it into the blue equation. I get -2, -1. And our final graph looks like this. Something to make connections. Do you remember that in our transformations unit, one of our parent graphs was 1/x? And the 1/x graph looked like this. This 1/x, we have a +1 in the bottom. That's moving it 1 to the left. So here we have the 1/x graph moved 1 to the left, but it has a hole in it because one of the non-permissible values had simplified and gone away.